Students, to determine the nature of a turning point, okay, we are able to use either the first derivative test or the second derivative test. There are two methods altogether, either the first derivative test or the second derivative test. Now I'm going to use this example to show you how to determine the nature using the first derivative test. Okay. Later on in the next video, I will use exactly the same example but using the second derivative test. Alright, so therefore, for the first derivative test, okay, we are going to differentiate it once. So the question says find coordinates of the stationary points. So therefore, we differentiate it once to find our dy dx. So differentiate it once, so it's negative 3x squared plus 3. Now, how are we going to find the coordinates of the stationary point? So what's so special about stationary point? Remember in the previous video, we know that at our stationary point, a certain value is 0. At stationary point, our dy dx is always 0. So from here, this part please remember. So we substitute negative 3x squared plus 3, which is our dy dx, to be 0. So from here, we have negative x squared plus 1 equals to 0. X squared minus 1 equals to 0. So therefore, x plus 1, x minus 1 equals to 0. Then we can solve for x. So x equals to negative 1 or x equals to 1. And note that the question says x must be greater than 0. So for x to be greater than 0, that means we need to reject the negative 1. So we know that at stationary point, the x coordinate is 1. So to find the coordinate, so when x equals to 1, we can find 1, which is negative 1 plus 3, to be equals to 2. So therefore, the coordinate of our stationary point is 1, 2. Now, the key is how to determine its nature. At the start of this video, I said before, there are two methods to determine the nature. So let us use the first derivative test. Now, using this table here, I will attempt to explain very quickly. Okay, so these are the points of our stationary point. Okay, all these marked x, they are our stationary point. Now, for this example, okay, the stationary point, the coordinate is 1, 2. That means the x coordinate is 1. Hypothetically, if this coordinate is 1, okay, this is a value of 1. If we substitute a value slightly smaller than 1, that means slightly to the left hand side, we will have a gradient of negative gradient. If we substitute a point slightly to the right, we will have a positive gradient. So if we have a value of 1, we can substitute a point slightly to the left, can be 0.9, a point slightly to the right will be 1.1. When we substitute inside, we see that the gradient changes from negative to positive. We know that the nature is a minimum. Same thing, if a point to the left, we substitute it, it's actually positive. And a point slightly to the right, we substitute it in, we know that it's negative. So therefore, it's actually a maximum point. Same concept. If we have a point of inflection, we see that the gradient changes from, actually it doesn't change, okay, it remains from negative to negative, is a point of inflection. Or a point slightly to the left, the point remains positive gradient, positive to positive, is also a point of inflection. So now let us see how we use this method to solve for this question. So therefore, I will choose to create a table. Okay, we have the value of x, then after which we have the sine of dy dx. Then I can have a sketch of our dy dx. Alright, so this is a table here. Okay, so we're going to have 3 points. So therefore I have a value of 1. So that means my value of 1. This value of 1, my dy dx, you know that is 0. So therefore it's a horizontal line. Okay, now a point slightly to the left. So that means 1 negative, slightly to the left. So I can use a point of 0.9. Okay, when we substitute 0.9 into the function for dy dx, you substitute it in. Okay, you'll notice that the sign or the gradient is actually positive. Alright, when we have negative 3, I can use a point 0.9 square plus 3. It gives us positive. So when it's positive, this is the shape. A point slightly to the right, that means it's bigger than 1, can be 1.1. We use negative 3, 1.1 square plus 3. You use your calculator, you'll notice that this gives us a negative value. If it's negative, it's a negative value, so therefore this is the shape. So therefore generally we know that the shape is a maximum curve. Alright, okay, so after this step, our solution. Okay, so therefore we'll continue from here. Therefore it is a maximum